Hello and welcome to Maths on the Move, the podcast from plus.maths.org. I'm Rachel Thomas. This month we really enjoyed meeting some young female mathematicians who were just finishing up their summer research projects through the Philippa Fawcett Internship Programme and the Cambridge Mathematics Placement Programme. We were running writing and editing workshops with them, and it was so fascinating to hear about their research projects and their hopes for their careers and to help them develop their ideas for communicating their work, no matter which part of industry or academia they head into. Now, as you walked into the workshop on the wall in the Centre for Mathematical Sciences, you walked past 6 inspiring portraits of female mathematicians from the University of Cambridge. These portraits form part of the Women of Mathematics photo exhibition, which celebrates female mathematicians from institutions throughout Europe and was launched in Berlin in the summer of 2016. When Cambridge hosted the exhibition in 2017, when the Cambridge mathematicians contributed their portraits, my colleague Marianne Freiberger had the opportunity to interview these women about their work and their mathematical lives. In today's podcast, we revisit our 2017 interview with Natalia Berloff, a professor of applied mathematics, who told us why maths is like a treasure hunt and told us about some of her adventures in the world of maths.
Natalia, would you please like to introduce yourself to start off with?
Okay, so my name is Natalia Berloff. I'm a professor of applied mathematics here at DAM.
Mm-hmm. And could you tell us how and when did you choose to do mathematics?
Age about 10, the usual age for this kind of thing. It just happened. I was reading tons of books, shelves after shelves, and on one shelf there were a lot of books about mathematics. Some were for children, like explaining graph theory, and I think I was suddenly completely taken by the theory, by how logic works to actually solve kind of unsolvable problems on graphs. So that was the beginning, and then I grew up in Russia, so we had very well developed Olympiad movement in mathematics. So I started winning on various levels. And once you get to some kind of a country level, then big players like Moscow State and Landau School start taking a notice of those people. So that's how I got lured into this wild world.
And what's it like, in particular, being a female mathematician?
Being a mathematician and then, female or male, I don't know, it makes such a big difference. We're defined by our profession.
Good. So, since you say that, is there any advice that you would give to a young woman wanting to enter mathematics, or do you think the advice is equal for both genders?
I think it's equal. I have a boy and a girl, a son and a daughter, so I give them the same advice,
What's your advice?
Advice is that being good in maths opens a lot of possibilities. You don't have to be a mathematician, but knowing mathematics opens the road for any sciences. Physics, chemistry, biology, you can do whatever you want.
And for you, what are the joys of doing mathematics and what are the challenges?
Treasure hunt.
In what sense?
No, but I mean that's exactly what we do. So we're trying to, to find our jewel, to find the treasure. In a sense, we have some leads. We're solving the problem. And there are hints, leads, but you need to find this holy grail, and then you start using different tools. You start learning different tools, different machinery that probably will help you to discover. And then it's also, I think, at first when you start being in mathematics or in physics, you start finding these little jewels, right? Little things, and you're very happy. But the more you go, the more you're really looking for a big thing. So, and that's where the excitement is about, just expecting that, you'll have this big breakthrough.
Okay. And could you explain what your area of mathematics is about?
It's applied mathematics. So I'm writing equations. I'm trying to understand the physical system. In my case, quantum fluids, superfluidity, Bose-Einstein condensation, and try to, for a given physical system, it could be liquid, it could be gas, it could be even solid state. I'm trying to write down the equations that describe the motions, that describe the phenomena observed, and then I'm in close contact with experimentalists trying to see if my theory works and what else they present that, it still doesn't fit into the model, so I can extend it and build a new one.
Okay. And could you describe one of your favorite mathematical moments, mathematical experiences that you've had?
There were many. Perhaps the first one, again, was when in this book that I mentioned, that I read when I was 10, there was this problem of given a set of points. A graph is a set of points with edges in between.
So like a network.
A network. Is it possible to actually go along every edge just once without taking your pen off the paper? So very simple problem. And the answer is brilliant, as it seemed to me when I was 10. And the answer is you count every node and how many passes are going out of this node. And if it's odd, it means that you will be able to start, go around, come, and leave. But if it's even, then you come, and go. Which means that only the graphs where you have two nodes with odd numbers is actually satisfy the property that you can go, and you have to start at the first odd and finish at the other one.
So surprisingly simple.
That was very simple, but before you try various graphs and you see that sometimes you don't know why it works, why it doesn't work, maybe you just didn't find the right way how to go between the points. But at the end, when you understand, and it makes perfect sense, right? And then you think, oh wow, now I can solve any problem because I know this trick. And I think for me being 10, that was kind of memorable moment.
Okay, great. Thank you very much.
Okay, thank you.
That was Natalia Berloff talking to my colleague Marianne Freiberger in 2017. You can see the Cambridge posters from the Women of Mathematics exhibition and find out more about their work and their mathematical lives at plus.maths.org/content/women. And stay tuned to this podcast for the rest of the interviews with these brilliant women of mathematics coming over the next few weeks. The music in this podcast is from the band Yusa, and the track is called Plankton. Thanks for listening, and bye-bye for now.